Hi, in this video I'm going to do the Sieve of Eratosthenese project, which is a kind of iterative way of finding prime numbers by marking off or eliminating numbers that can't be prime numbers because they're multiples of prime numbers. So start up, find the multiples of 2 because 2 is prime, and then those can't be prime. Find the multiples of 3, those can't be prime. Find the multiples of 4. Oh, well, 4 is a multiple of 2, so you can skip that one. 5 is prime. Mark off the multiples of 5 as not being prime. So that's what we're going to do. It's a really cool little program to watch it run. There's actually a pretty good version on Wikipedia. This is what we're going to try to make right here. You can see it marking off composite numbers. Numbers that can't be prime, and what you're left over with then are the prime numbers. So what we're going to do is make a grid of 10 by 10 text boxes, but we're not going to do it inside of the XAML because that would be horrible and slow and tedious. What I've done here is I've named my grid Grid 1, and that way I'll be able to add the controls to the grid programmatically. So that's all you have to do in your XAML is I changed my height and width, or I changed my width to 600 to make the thing a little more square, and I gave the thing a nice name, and I gave my grid a name so I can access it from within my code. That's all I need to do. All right, let's go over to the C# code. And I'm going to follow along with my own packet here, and hopefully it'll work. So there we go. Create a new WPF application. Yep, done, done, done. Okay, so I'm going to need a dispatcher timer to drive this thing. So that's why I need system.windows.threading. So let's go to the code, and up here, boom. Now we've got our library. What else we need? Okay, so what is this stuff? We are going to need to keep track of like what our prime number is and then which multiple of the prime number we're looking at. So this is going to be driven by a timer, and multiple is going to go up by 1 every time the timer ticks. So we'll have 2 times 2, 2 times 3, 2 times 4, 2 times 5. And that's how we're going to mark off the composite numbers, the multiples of the prime number. And the base number is what prime number we're starting with. And then in order to change the background properties of our text boxes, we have to store them somehow. So we're going to have an array of 100 text boxes. And then we've got a timer to drive the whole thing. So that's what this is. And then what is all this? Well, we're going to have an array of brushes so we can just pick colors to change, to set the backgrounds to, so we can just watch the program run. So that's all that stuff is. We just need to put this in our class. So I'm going to take all this, and I'm going to put that in my class. And did I put that in the right place? Yeah, it looks like I did. Okay, so let's just fix the tabbing though. Tab, 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 tab. Okay, so I'm good there. So there's my prime number, the multiple of the prime number I just computed, or I'm going to compute, all the text boxes that I'm going to add to my form so I can change their background color to mark them as composite, a timer to drive the whole thing, and then an array of brushes so I can make everything look pretty. All right, let's go build our user interface. I'm going to make a function called, I don't know, make boxes. Come on, void make boxes. There we go. So what do I do inside of make boxes? And then let me make sure I call make boxes from my constructor. So here's where I'm going to configure the user interface. I'm going to turn the grid lines on. That'll just make the thing look a little prettier. Grid1 dot show grid lines equals true. There we go. I'll just make things look pretty. And then let me add 10 rows and 10 columns to the grid. So let's use a for loop for that. FOR, tab, tab. Let's run 10 times. So let me add a row definition to grid 1 and a column definition to grid 1. Grid 1 dot row definitions dot add new, and then I'll just give it a new empty row definition, and that'll make it happy. And then let me put in a column definition as well. Column definitions. And that's going to have to be a column definition. Yay, now my grid now has a 10 by 10 kind of lattice work where I can hang controls. And now what I need to do is actually make the text boxes and hang them onto the grid. But I'm going to make these in a kind of a row column fashion. So what I need there is a loop inside a loop, a nested loop. So one loop will be driving the columns and the other will be driving the rows. And I'll make this go to 10. And I'll call this guy J, and it'll also go to 10. So this will give me a 10 by 10 grid in here. So rather than type in all this, what we're going to do is make a text box and attach it to the grid. So I'm going to make a text box here called T, and I'm going to say it's equal to a new text box. And now I'm going to set some properties on it just to make it look pretty, and I'm going to put the number in the text box. This is a lot of ugly typing, so I've just put this all in the document here. So what this is just setting the properties on the text box to make it look correct. This is putting the correct text in the box. This is assigning the box to our array so we can reference it later. And then this is where we append it to the grid. We're going to say, so the grid maintains a collection called children that you can add new controls to. So we're making this text box and calling it T and appending it to our grid. And then we're using grid.setColumn and grid.setRow to set the row and column for that control so it'll go to the right place. So I'm going to take this and paste it in here. I think I may have it twice now. I guess I don't need it twice. And I could do this all C# style up here with the open curly brace and then specify the name value pairs inside of the curly braces, but I could do it this way as well. And then this text is assigning the correct number to the text box. So when like I is 0 and J is 0, this is 1 plus 0. So I'll get 1 in the text box. When I is 1 and J is 1, I'll get 1 plus 1 times 10. So I should get, well, whatever. But the plus 1 is accounting for the fact that the for loops start at 0, but our numbers start at 1. So that's what's going on there. And then our array starts at 0, so we don't have the plus 1. So let's run that and just see that it works. Yay, it works. It's pretty. So we added all these controls. Right, this runs 100 times. This inner loop runs 100 times, 10 times 10 times, and that's how we get our nice pretty interface. All right, so now let's go implement this guy, the one that's in the flow chart. So what does this do? Well, every time our clock ticks, we are going to compute the next composite number, and if that's gone off the table, then we've got to go over to the next prime number and reset our multiple back to 2 and start counting up at the next prime number. And if our base number, the prime number, goes off the end of the table, if it gets bigger than 100, then we've exhausted the search space. So that's what this first check does. If our base number, which is our prime number, goes past 100, then we've exhausted our search space. So just shut everything off and reset it. And just pop up a message box that says you're done. Otherwise, compute the next composite number. If it went past the end of the table, if it went greater than 100, then then we got to find the next prime number and start counting up multiples from there. Otherwise, just change the background color of the text box to mark that it is a composite number. So if the product is less than 100, less than or equal to 100, mark it as composite. Otherwise, we went too far, and we got to go up. We got to reset our multiple to the beginning and go to the next prime number. And that's it. All right. So let's do that first part right there. If the base number is greater than 100, greater than or equal to 100, shut off the whole deal, and kind of just say we're done. So let's make a function called tick, and this will be an event handler. So it'll take a control, the sender, the control that initiated the event, and an event args structure called E that we'll just call it E. If tab base number greater than or equal to 100. Was it greater than or equal to? It's got to be. Yeah. Okay. I think greater than 100. be technically correct. Either way. Then shut off the timer. Timer.stop. All right, and then let's pop up a message box. Message box.show. That works in WinForms too. Done. All right, so this is going to halt the program until they click OK, and then we're going to reset our timer. So what do? We set our base number back to 2. We set our multiple back to 2. And now we want to reset the background colors of all the boxes to white. And we've got all our text boxes in this array up here called boxes. We'll just use a for each loop, iterate over that, set the background colors all back to white. For each, tab, text box T in boxes T dot background equals brushes dot white. No, capital brushes. And then finally restart the timer. Timer dot start. I think we're good there. Let's just double check the flow chart that we got everything. Multiple and base number to 2, restart timer, clear everything. All right, good. Okay, so it doesn't matter if we return or we have an else if or whatever, or if we just keep chugging through here, it's still going to work. Let's compute the next composite number, and that's our base number times our multiple. So let's call it product. Or sure. Equals base number. We could call it composite. Next composite. I don't know. Times multiple. All right. So if it's greater than 100, then we need to find next prime. And start over with the multiples. Otherwise, and I didn't want that semicolon there, mark number as composite. All right, this is the harder bit, so let's do that last. How do I mark a number as composite? So the product, what's the product? Well, okay. Well, if the product is 99, I want the 99 to be marked as composite. Text boxes, so I'm just going to set its background. Set its background property. Boxes, square brackets, product, dot background, equals brushes. No, lowercase brushes. I want to use my array of brushes. Which brush do I pick? Let me use the product. No, the base number. I'm going to use the base number. So all the multiples of a number will have the same color. Okay, so there's two problems here. The text boxes start at 0, not 1. So I need to subtract 1 off my product. And the base number could be bigger than 10. So let me mod it by 10. Oh, I don't need the parenthesis. I'll just say mod 10. Mod the base number by 10, and that'll bring it back into range. And then what I want to do is add 1 to the multiple. So the next time the timer ticks, I get the next composite number. Multiple plus plus. There we go. All right. So that's the bit. We just did this bit right here. Change the background color of the text box for the composite number and increment the multiple. All right. So that's the part we did. If we've gone past 100, though, then what we need to do is start over counting up multiples of the next prime number. So how do we find the next prime number? We start looking up through the text boxes until we find one whose background color is white, because that hasn't been marked yet. And also, it's got to be less than 100. Otherwise, we'll go off the end of our table. So set multiple to 2. That's easy. Multiple equals 2, and then find next prime. So this is, we've got to scan, but we don't know how many times, and we know we want to scan at least once. So this is the kind of the situation where we want to use a do while loop. And we want to scan as long as the background color of the text box is, well, we want to keep incrementing our base number, going up and trying to find a text box that's still white. So let's add 1 to our base number. And if we can find a text box, base number, whose background color does not equal white. So this will, no, brushes.white. We're going to scan up until we find a white box. You know, as long as it's not white, keep going, and if it stops, then you did find a white box. And the base number is less than 100 or less than 99. Maybe less than 100 would probably work too. I just don't want to go past the end of the table. Okay. That's a little ugly. It'd be kind of nice to have that all kind of grouped together, but I guess we can't. Find the next, anyway, we're scanning up, looking for the next kind of open box to start start up our multiples in. And then that was it. Set multiple to 2, increment the base number until we find the next prime. All right, and then up here, right, if our prime number is too big, then we just stop. So let's save it, and then this won't run yet because we haven't actually started our timer. We need a function. We need to start a timer that's going to call this. So let's go initialize our timer. Timer.interval equals new. So the interval is a time span object. New time span. Seconds, milliseconds. Let's make it fast. And let's set the timer's tick function to be our tick function. And then let's start the timer. There we go. All right, so start the timer, and our base number and multiple is assigned but never used. How is that? That is making me nervous. That's interesting. Maybe it can't tell that that function is going to get called because it's being done through an event handler. All right, well, let's run it and see what it does. So now it's doing multiples of 2. Then it should do multiples of 3. That's a little light. Okay, now multiples of 4. It can skip 4. Now it's doing well, it looked like it did multiples of 10 there. No. I can't tell which one it's working on. Something seems to not be quite right. We should have seen multiples of 5. All right, time to investigate. And boom. All right, I shall investigate. Okay, well, the line where it blew up, you know, gives you the hint. So it was an off by one issue. So if I want the box for the number 3, that's actually box 2 because the indexes start at 0. I just forgot the -1. I got so excited. There you go. And then I don't know. I don't really like the colors. Maybe I'll change some of the colors. There's too many light things. I don't know. You know, like, I don't know if we're ever gonna. Well, we should see red on there, but I don't know. Now I'm freaking out about the colors. That doesn't make any sense at all. Why am I caring about the colors? I guess I just am. But there it is. So now if I run this, you can see it's doing the multiples of 2, and now we'll see it do multiples of 3 when it's done. There are the multiples of 3, and you can see the multiples start at 2 because we don't want to. The 3 is prime. We don't want to mark it as composite. And now it's doing multiples of 5. Then it's going to skip 6 and do multiples of 7. Then it's going to do the multiples of 11, which it just did. Then multiples of 13. And it's going to keep going up and up and up until it's done. There you go. Whee! Fun to watch. All right, there it is. Prime numbers.